China just set a Guinness World Record that the entire automotive industry said was impossible. A car that travels 2,000 kilometers on a single tank of fuel. For decades, the best engineers in the world tried to build something like this. They got close, celebrated it as the pinnacle of what physics would allow, and then declared the chase over. There was nowhere left to go. Western automakers believed them. They stopped trying. They abandoned combustion engine research and went all in on electric. China didn't stop. And now the world record belongs to them. Not to the Germans who invented the engine, not to the Japanese who spent 50 years perfecting it, to a Chinese company that didn't even exist 15 years ago. What did they build that made the impossible possible? Every time you press the accelerator, something is being wasted, and most people don't realize how much. Fuel catches fire inside your engine, and the explosion pushes pistons that turn your wheels, but most of that energy never reaches the road. When fuel burns, it creates massive heat that spreads into the metal walls, out through the exhaust, and into the air around the engine block, and the engine fights to keep that energy pointed in one useful direction while losing most of that battle every single time. A normal car only uses about 30% of the energy in the fuel you pump in, and the other 70% disappears as wasted heat. For over 100 years, engineers have been trying to shrink that waste, and going from 30% to 35% took decades, while moving from 35 to 40 became one of the most expensive engineering challenges in automotive history. The best any mass-produced car engine had ever achieved was 41%, and engineers celebrated that number like a moon landing after spending 20 years and billions of dollars to get there. Then they told the world it was the ceiling, and going higher would push against what the laws of physics allowed. There's a rule in thermodynamics called the Carnot limit that sets a hard ceiling on how efficient any heat engine can be. Make the explosion too hot and you melt your engine, but keep the exhaust too cold and your pollution control stops working. So engineers treated 40% like a brick wall. That assumption was wrong. While Western engineers were declaring victory at 41%, something started happening in China that nobody in the industry took seriously, because Chinese automakers weren't asking how to squeeze another percentage point out of existing engine designs, but were asking a completely different question. What if we just started over from scratch? The first crack in the wall came from BYD in 2024, and the company looked at the traditional hybrid car design and called the whole approach outdated. In a standard hybrid, the engine and electric motor both work to drive the wheels at the same time, so the engine constantly changes speeds as it revs up on hills, slows down at traffic lights, and shifts through gears, which means every time the engine speed changes, it drifts away from the zone where it runs most efficiently. BYD had a different idea, and they decided the engine shouldn't drive the wheels at all, so it could just stay at one perfect speed and act purely as a generator making electricity, while the wheels would be driven entirely by electric motors. Because the engine no longer had to chase the road, BYD could tune it obsessively for that single operating point with no compromises and no trade-offs. And the result was their DMI system that hit 46.06% thermal efficiency. The global automotive press was genuinely stunned because a 5% jump in efficiency sounds modest until you realize it took the best engineers in the world roughly 20 years to gain the 5% that brought them from 36 to 41. And BYD did it in a fraction of the time with a fundamentally different approach. Legacy automakers had a quiet moment of panic, but then most of them went back to their roadmaps and told themselves this was a regional story that Western consumers wouldn't accept. They said the same thing about Japanese automakers in the 1980s, and we all know how that ended. But while the industry was still trying to process BYD's achievement, Geely had already been working for 2 years on something that would make even 46% look like a warm-up act. On April 13th, 2026, Geely held a press conference and put a number on the screen that most engineers watching thought was a typo: 48.41%, certified and officially measured and recognized as a Guinness World Record. The achievement didn't just beat the previous record, but shattered the entire framework of what the industry believed was possible. And the key to breaking through that ceiling starts inside the combustion chamber itself, in a place nobody thought to look. Inside a normal engine, air and fuel don't mix evenly when they get pulled into the cylinder. And you can think about pouring cream into coffee without stirring to see the same pattern of uneven swirls where some spots are thick with cream, while other spots are mostly coffee. The same thing happens in a cylinder, where you get pockets with too much fuel and pockets with too little. And when the spark plug fires into that uneven mixture, the flame doesn't spread all at once but starts at the spark and slowly ripples outward like a wave crawling across a pond. While that wave is moving across the chamber, heat from the first burst is already bleeding into the metal walls. So by the time the whole mixture has burned, a significant chunk of energy is gone to the engine block itself. Geely's engineers solved this with what they call the fire tornado combustion system, and they completely redesigned the shape and angle of the air intake channels so that when the intake valve opens, incoming air isn't just pulled in passively, but is forced into a high-speed spinning vortex that creates a literal controlled tornado inside the cylinder. When the spark plug fires into that spinning tornado, the flame doesn't slowly creep across the chamber, but explodes outward in all directions simultaneously because the fuel and air are already perfectly blended from the turbulent spinning. The combustion is sharp and clean and synchronized, so almost all the energy goes straight down onto the piston before heat has a chance to leak into the walls, which means less wasted heat, less pollution, more force on the piston, and more efficiency. But cranking up combustion like this creates a new problem. The hotter and more compressed your explosion, the more likely you are to cause engine knock, which is when fuel ignites before the spark plug even fires and creates an uncontrolled bang that can crack pistons and destroy an engine within minutes. Solving the knock problem is what kept engineers stuck below 41% for so long, and Geely's answer is just as clever as the tornado itself. They made the engine run hot and cold at the same time in different zones on purpose, because most cars send water through the entire engine at roughly the same temperature in a one-size-fits-all compromise. But the top of the engine and the bottom don't need the same thing. Geely split the cooling system into two completely independent zones, where the cylinder head at the very top where explosions happen stays extremely cold, while coolant flows fast and aggressively through this zone to pull heat away the moment it appears. Keeping the top cold means the air charge stays dense and cool right up until ignition, which prevents premature detonation and allows the engine to run at a far higher compression ratio than would normally be safe. And more compression means more energy extracted from every single explosion. Meanwhile, the engine block down below, where pistons slide up and down thousands of times a minute, stays deliberately warm, because warmth thins out the engine oil, and thinner oil means pistons slide with dramatically less friction. Every tiny bit of friction eliminated is energy that reaches the wheels instead of being wasted as heat from metal grinding against metal, so you end up with an engine that's cold at the top to allow massive compression and warm at the bottom to minimize friction, even though in traditional engine design those two goals conflict. Geely built a system where both happen simultaneously in different parts of the same engine, and the whole thing is managed by an electronic water pump that reads engine conditions dozens of times per second and adjusts coolant flow instantly. Nobody else was building it because conventional wisdom said the trade-offs made it pointless. But even the most efficient engine ever built is only half the story, because getting all that energy to the wheels without losing it in a complicated gearbox is the other half. Traditional automatic gearboxes are mechanical masterpieces, but they're also heavy and full of friction, because an 8 or 9-speed automatic has hundreds of individual moving parts, including clutch packs and hydraulic torque converters and shift forks and synchronizers. And every single one of those parts absorbs a little bit of the energy you just worked so hard to generate. The whole system can weigh over 100 kilograms and still waste a meaningful percentage of the engine's output before power ever reaches your wheels. Geely looked at all of that and started from a blank sheet of paper, and what they built is called the 11-in-1 intelligent drive system that works as an electromechanical power router rather than a gearbox. It packages the engine and the generator and 2 electric motors and the high-voltage inverters and the thermal management hardware all into one single compact housing, which dropped total powertrain weight by 13.5% compared to traditional hybrid setups, while eliminating shift forks and hydraulic fluid channels and torque converters entirely. For about 90% of your daily driving, the combustion engine has zero physical connection to your wheels at all, because the engine runs at its perfect efficiency sweet spot and powers a generator, while that electricity goes either to the battery or directly to the electric motors spinning the wheels. From the driver's seat, the whole experience feels like a fully electric car with silent and smooth operation and instant torque from the moment you press the pedal. The only time the system physically connects the engine to the axle is at steady, high-speed highway cruising, because at around 130 km per hour and above, routing power through the electric motors actually wastes more energy than a direct mechanical connection. The system automatically detects that condition and locks the engine to the wheels like a top gear, while bypassing the electrical conversion entirely. Managing all of this is an AI system that recalculates the most efficient way to route power 50 times every single second, and it reads your navigation map and spots the hill coming up 3 kilometers ahead and decides in real time whether to charge the battery now and coast down the other side, or use the battery now and let the engine recharge on the descent. The combined result of all of this, the fire tornado combustion and the split thermal zones and the 11-in-1 drive unit and the AI power routing, is a certified fuel consumption figure of 2.22 liters per 100 kilometers, which is a Guinness World Record. On a full tank, the range is over 2,000 kilometers, and those numbers change the conversation about what a car can actually be. Pure electric vehicles are great in the right conditions, with their silent operation and efficient performance and zero tailpipe emissions, but they come with trade-offs. Millions of buyers aren't ready to accept, including large battery packs weighing over 500 kilograms and thin charging infrastructure across huge parts of the globe, and range anxiety as a real practical barrier. Geely's system represents a completely different path, where you get the smooth and silent and instant torque of a fully electric car for daily driving, while your total range is over 2,000 kilometers, and you can fill up at any petrol station on the planet with no charging network needed, and fuel cost per kilometer comparable to pure electric in most markets. And this isn't a small commuter, but a full-size SUV burning less than 2.5 liters per 100 kilometers. For Western and Japanese automakers, this creates a difficult challenge, because the internal combustion engine was invented in Europe, where Germany and France and Britain dominated it for over a century, while Japan refined it to near perfection over 50 years. But the record now belongs to a company that didn't have serious global presence 15 years ago. Closing that gap requires rebuilding engineering pipelines and asking different questions and funding years of research, which is difficult when investors are pushing you toward full electric, while your combustion technology falls further behind. Legacy automakers will eventually respond, but the question is how much ground shifts in the meantime, because what Geely proved is that the combustion engine still had enormous life left, and the limit was never the laws of physics, but the limits of what people believed was worth trying. When Western engineers declared 41% the finish line and walked away, Chinese engineers saw an opportunity, and while the rest of the industry placed bets on full electric, China kept working on both paths. So now they lead in combustion efficiency and electric vehicle production simultaneously. History has a pattern where American automakers dominated until Japanese manufacturers proved that quality and efficiency could be built at scale, and Detroit dismissed them as regional, until suddenly Toyota and Honda were everywhere. The same dismissive response is happening again, with claims about regional stories and different markets and different consumer preferences. But the numbers suggest otherwise. The Guinness World Record isn't regional, and physics works the same everywhere, and consumers everywhere care about range and fuel cost and not being stranded looking for chargers. The automotive industry just learned an expensive lesson, which is that declaring a problem solved doesn't mean it's actually solved, but just means you stop trying. And while you're not looking, someone else might figure out what you missed. What do you think? Does the 48% hybrid represent the smartest bridge to a fully electric future? Or will pure electric vehicles leapfrog all of this faster than anyone expects? Let me know in the comments. If you want to see more videos like this, hit the like button and subscribe. Thanks for watching.